Hello guys, this is Kudo, and today in this video we'll continue our series video about how to make a Mario 2D, and in this video we'll be interested on how to move Mario left and right, so let's get into it. So last time I let you with the basic input, so we are able to make the fire, the jump, the crouch and the move, so we start to making the function on move, on jumps, on crouch, etc. But now what we want to do, we want to implement some of these functions. So again in this video we'll only be interested by the on move. The on jump will come after. So the first thing you will need to do, if you didn't do it on the last video, make sure your Mario 2D player have a rigid body and also add a 2D box collider. So let's add a 2D box collider like this. And in this 2D box collider, what we want to do, so let me just move up this component. So move up because I want this to be at the same page of the rigid body. And as you can see over there, if I zoom in on the Mario, as you can see here, let me just click on the Mario 2D. We got the box collider over there. So what we want to do, we want to change a little bit his size. Don't worry, I will explain it after. So I want to put 0.8 over there, and the edge radius I want to be at 0.01. So why I'm doing this? Because I'm using a box collider 2D, as you can see, the edge should not be like a right angle. I want to be a little bit curved. And why? Because when you will hit like the pipe or something like that, you will not be stuck. And don't worry, we will add, but in other video, the possibility to add like a no friction zone. Anyway, so right now, also what I want to do on the ground function, as you can see over there, we want to add this to this ground a layer. So to do that, what we want to do, we just want to go on layer and want to add the layer, and we want to add basically, so I think you guessed it, the layer ground, because this will represent the ground. And this is why it's very important to separate everything we just make with the 2D level design. So right now, as you can see, all the ground is represented by the ground. And as you can see over there, we all the ground is on the rigid body, and we got the composite collider 2D. So if I so let me just select here the ground. If I now let me clear the console, and if I now click play over there, you will see Mario will be able to stand on the ground. So okay, let me click play. You will see Mario will do some crazy stuff. So make sure first, so on the Mario 2D player, let's go on constraint. Let's freeze the rotation because we don't want Mario to flip or do something we don't want to. And also on the parent background we create, we make a main background with the polygon collider 2D. Make sure to check this as is trigger. So now we can save this, and now again let's hit play and let's see. So like that, Mario is standing on the ground right now. So that's nice. Even if I click on him, no, that's not the good one. So here, click on him and maybe go up. As you can see, he's coming down. Okay, so now we just fix the collider, make the rigid body. So what we want to do, so let me open Visual Studio Code like that. So what we want to do, so let me just add some variables. So we will need, so let's create so a serialized field. So serialized field, let's add so private rigid body 2D. So private rigid body 2D. And let's name this basically rigid body 2D player. So again, we are in the player controller script. So okay, I create the sys. I also need, so let me again create serialized field. So private box collider. So again, private box collider 2D like this. And again, let's name this so box collider. So box collider 2D, and again, it's a box collider 2D player. Okay, so now we can save this. So to make sure everything works perfectly, so I will also create like a header. So let's create a header. It will help me so clean all the code and make sure everything is good. And let's name this physics. physics object, okay, like that. And we also need to do other stuff. So let's again create, let's serialize some other field. We will need to create a private sprite renderer, sprite renderer, and let's name this sprite renderer player, like this. Why we will need this? Because when Mario will go on the left to go on the right, we will need to flip this image to be able to see where Mario came from. Okay, and last thing we need to do, so we also need, I prepare the other stuff. So let's again serialize field. So let's create a private, so this one will be an input action reference. So input action reference, input action reference, and this will reference to the player input. So player input action reference move. So action reference move. And I will do the same for the jump. So player input action reference jump. Okay, so we can save this. So again, I will, because I want to make everything good, I will create again a header. Let's make this like input action. Let's create not player settings, but input action. So input action reference. Okay, so I misspell reference. Let me just like this. Okay, and for this one, so again, let's create another header. So header, and let's name this player component here, like that. Okay, okay, and what I forget, oh yeah, one too much. Okay, so this is a component I will need. So let me add also some other components. So again, I will create a serialized field, and let's create a private layer mask. So because I will need to handle the layer mask to be able to see if the player is touching the ground, touching the brick, or facing a pipe. So I will need some of it. So let's create a private layer mask. So layer mask, and let's name this ground, pipe, bricks layer mask. So basically this one will take the ground, the pipe, the brick, and the brick layer mask. It will be useful after. So again, let's create another serialized field, and this one, so I want to use not the ground layer mask, but only the brick layer mask. So brick layer mask, and I want to do a last one. So let's serialize some field again, and let's create a private layer mask, again layer mask, and let's name this one pipe layer mask. So layer mask and pipe layer mask. Okay, and again, let's create a header, and let's name this layer. Okay, that's it. So let's head back to Unity. And what we want to do, we also, because we already create the layer, so let me add the layer, and let me add the layer of, so we create the ground, and let's create the layer of the brick, so like this. And also we want to create the pipe layer. So now if I head back to Mario 2D player, as you can see, we create the layer, and the layer is showing over there. So again, let's click on Mario 2D player. Let's go on the player controller, make sure it's checked, and we want to drag and drop the rigid body, the box collider, the player component, etc., etc. So basically we just need to drag and drop this, so the rigid body, the box collider. We also need the sprite renderer. So because we already add the sprite renderer over there, we just again need to drag and drop them like this. And we want to add the player input reference move and jump. So to do that, we just want to click on player input action over there, here. And if you open this list over there, you will see crouch, fire, jump, etc., etc. So we just need to drag and drop the move for the move, and the jump for the jump. But don't worry, the jump will handle this just after. I will explain it after why I need to do that. So let's head back to Visual Studio Code. Okay, and we also need to handle other variable. So let me just create other variable. So here, and let's create so private float speed. So I will need to handle the speed of Mario like this. And so we'll need, so let's create a private vector2, so a vector2, and we want to have the velocity of our player because we'll move Mario with the velocity of the rigid body. Okay, so I will need the velocity. So I will need another vector2, so private vector2, and I will need to get the input, so get the input value with the keyboard. So get input value, so input value. So I will also need another private vector2, so private vector2, and this will be the previous input value. Why, you will ask me? Because when Mario will switch direction, we will need to see if Mario is still sliding or not. Don't worry, I will explain it just after, and you will understand why I will need to do that. What I will need to add, so along with the speed, I will need to check. So so let me create a boolean. So I will separate this with vector2 float, and I will need a boolean. So private bool is player grounded. So is player grounded to check if basically the player is grounded. So by default it will be equal to false. So I also need to add another boolean. So private bool is player facing pipe. So is player face pipe. Oh, okay, and it will be equal to false. So I will need also, so I will declare all the variable I will need it. Maybe in this video I will not use everything, but at least it will be declared. So let's create a private bool again, is player, so is player jumping, because we want to check if the player is jumping. So again, by default it will be equal to false. What I will need to add, so let's create another, so not bool, but this time float. So let's create a private float. So we want to check the gravity speed fall. So gravity speed fall, like this. Okay. What we also need, so let's create another private, so this we handle the jump. So private float, again another float, and this will be the max jump height to avoid jumping too high. So this one will be equal, so I fix this to 5, like this, 5.0f, like this. Okay. And one last thing we want to do, so let's create another private float, and we want to add the max jump time. So max jump time. So basically, when he will hold the space button to jump, how long he can handle this. So I will put 1.0f, so 1 second. And with that, we almost finish setting all the variable we need. So there are other variables we need, but I will add them after, because right now we just want to focus on how to move Mario. So let me just quickly add another one, because this one will be needed in this video. So private again bool, and we want to check if is player, so is player running fast, and this one by default it will be equal also to false. So I will also need to add 2 more variables, and don't worry, after we'll start coding the thing, but it's very important to set a lot of stuff, because you may not see this, but Mario 2D game was a very difficult game to code for back in the day, and it is very interesting to see how they code this. So what I want to do here is create a private float, and I want to have the check distance ground. So let's create a distance check ground, so ground, and we want one to be default. And I will explain it later in another video why I need the default one. So this default one I want to be 0.1f, and I want also another private distance check ground, and this one will be at 0 also dot 1. So why I need two of it? Because the ground the ground distance check will maybe basically be updating, because when Mario will kill enemy, basically Mario jump on his enemy. So this is why it is the only time when the check ground will be updated, because basically when Mario will hit the head of an enemy, it's basically touching the ground, and we will need to check this. So now we can save this, and we want to create our first function. So basically check if the player is grounded. So I will do this over there. So let me create a private void update function. So I will use this one like this. And what we want to do in this private void update function, we just want to be able to, so I will put a to do over there, so to do, and we want here to check if player check if player is grounded, so is grounded and facing the pipe, so facing the pipe, to basically handle the thing when Mario is moving or not. We also need, so I will add in this video I will add a lot of to do, because I will not do everything in this video because it will be too long. So I also need here to put a to do. So we need to handle also, so we need to handle the state, so the state here of the player and the game. So basically if the game is over, if the game is playing, if the game is in pause, or basically if the player is dead. So we need to handle this. We also need to handle over there the gravity applied to, so to do here check gravity to the player. So this is the three things we need to do. So also in the will also create a fix update. So fix update. So I will use this one, yeah. And in the fix update again, we need to make a to do. So to do handle physics player, basically to move player, and because we are using velocity and we are using rigid body, we'll apply everything in the fix update. And what we want to do, we also need to check basically the handle state of the game and the player. So we'll also add a to do. So let's handle the first to do, so the check if player is grounded and face pipe. So to do that, what we want to do, we want to create a function. So let's create a private void check player grounded and face pipe. Okay, and in this function, what we need to do, we will update the boolean, so this one, so the is player is grounded and is player facing pipe. So so for doing that, what we want to do, so we want to handle the boolean, so is player grounded, and we want to say is player grounded will be equal, so basically Cody already know what I will do. So I will use the physics 2D box cast, so physics 2D, so physics 2D, so physics 2D dot boxcast, so boxcast. And what we want to add in this parameter, we want to add basically the box collider 2D player bounce center. So as you can see, it's writing over there. We want to here add the vector size. So as you can see on the tooltip, we can see what parameter we need. So the origin will be the center of Mario, the size we want, so the box collider bounce size. After that, the float angle, we want to be at 0. We want to check the ground, so we'll face down the player, and what type, at what distance we want to check the ground, so basically the distance check ground, and what type of layer we want to check, so basically the ground, pipe, brick, and layer mask. So we will need this, this, and this. So if I head back to Unity, so if I summarize everything, basically, so let me just quickly remove this, because it's too much like this, or maybe not remove it, but yeah, like this. Okay, so basically, if I summarize everything, basically this will create a box, the physics box cast handle the box collider over there. He will start on the center. He will get the size of the box over there. He will make a raycast over there at 0.1, and he will check if here we are touching the ground or not. And this will work with the pipe and the brick, because remember, if we move Mario and he jump on one brick, just imagine the brick is over there, so he will able to check if is on the brick. And same for the pipe. So maybe if Mario is standing on a pipe over there, as you can see, he will be able to check if basically Mario is on the pipe or not. So this is why it's very important to use this. So let me just like this. And let me head back to Unity, Visual Studio Code, and we'll do the same for facing the pipe. So for facing the pipe, it will do the same. So again, we'll check is player facing pipe with box cast, box collider 2D center. Again, we want the box collider bound size 0, and now we want the vector right, because we want to check at the right, and also we need to check at the left, but we'll make a little difference over there. And here we want to put the distance check ground and the pipe player mask. So I will do this over there. So here I will add, so basically a ternary operator. So basically I will say if the sprite, so sprite player render player dot x dot flip x, so dot flip x. So if the player is not flipping on the x, we want to face on the vector right, else we want to flip on the vector, so vector left, like this. Also, what we want to do, because the distance check ground is evolving, maybe if we jump on the character, we want to change this not on the check ground but on the default one, so like this. We stay at 0, and we want to check not only the pipe, but we want also to check if it's facing, maybe, so if I head back to Unity, I want to check if it's facing the pipe, or if it's facing any ground over there, or maybe a brick when he will jump like this and if facing the brick. So maybe the name of the variable is not accurate, so let me just rename this. So is player facing anything, so rename symbol is player facing facing anything, like this. And we want also to check all the layer over there, here and here. So now we can save this. And one last thing we want to check, so I forget to declare this variable, so let me quickly declare it. So we want to create, so a private bool, so it will be able to use after in other video, but I will check here it over there. So private bool here is player, so basically is player head touching brick, so touching bricks. So by default it will be equal to false. So basically we'll check if Mario jump under the brick, he will need to do some stuff. So to make this, I use raycast. So let me quickly make it. So I will need to raycast it. So raycast it 2D. Why I need use raycast? Because I will need to check what kind of box is hitting. So this is why I use raycast. So let me create raycast it. So I will name this it 2D, and this will be equal to the physics box again. So let me physics 2D docs.box cast, and it will take in parameter basically the box collider 2D, so box collider 2D player dot bound center, so bound center, like this. And it will take the box collider 2D player bound size 0. We don't need to have check over there. We want basically, because we are checking the vector, the head, we want to use vector up, so vector2 dot up, like this. And again, we use distance check ground default because this should not be updating. And we want again to check the ground, pipe, brick, and layer mask like this. And after that, we want to say is player header touching bricks will be equal to hit 2D like that. So here what we want to do, so after checking everything, so here we want to check, so if is player grounded, what we want to do. So basically here, if the player is grounded, we want to make the velocity, so the velocity of the player dot y, so moving horizontal way, will be equal. So we want to make a matf dot max. We want to take the maximum between the velocity of y, so velocity dot y, and 0. We also want to say, so is player jumping, so is player jumping will be equal basically to false because the player is grounded like this. We want to add a to-do over there, so to-do. So next time we'll go through the code, we want to check the resize of the collider, but don't worry, I will explain it after. Why the resize of the collider? Because remember, Mario got different states, the small Mario and the big Mario. So we need to handle the collider. Maybe if he eats something during he jumps, so we need to check this. Also, we need to handle the animation. So to do, we need to handle animation when he's grounded. Okay, so else if it's not grounded, what we want to do? Else we want to say, so if it's not grounded, it's meaning the player is jumping equal to true. And again, we need to handle the collider after and handle the animation after. Okay, so I will put a lot of to do here because there are a lot of things to do here. So after that, we don't want to implement this right away, but again, I will put a to do. We want here, so again, a to do. Don't need to forget to handle the collision, so the collision of the brick head over there. So we need to handle this here, but we will make it after. And we want here to use our boolean is player facing anything. So if player is player facing anything equal to true, we want to say the velocity. So velocity dot x will be equal to 0. And we want to, so velocity of x equal to 0. And after, we will need to make another to do. So handle not collision, but all the animation. Handle the animation over there. Okay, and else, if it's not facing anything, so else, we want to say the velocity dot x will be equal to, so the get value input, so get input value dot x multiply by speed. Let me just quickly rename this. So I will say speed player because I use player anyway, so not hashcode, but x will be equal to this. Okay, so now we check everything. So I will also add here a to do. So I will also need to check, so to do here the check pipe interaction. So pipe interaction, because we want to check, but don't worry, I will explain it in another video because right now we didn't even move Mario, we just make all the check over there. So do not forget to call this function here, so in the fix update, in the update function here. So check if players ground and face pipe, so it's here. So we finish the to do like that. Okay, so we can save this, and now we want to move the player. So let me create a function to move basically the player. So it's here, handle the state of the player, handle the physics, and handle the physics of the player. So basically to move the player, it's very easy. So let me create a function. So let's create a private void And what we want to do is move, create a function called move player. And in this move player, it's very easy. We want to say rigid body 2D player dot velocity. Okay, I didn't know that. So basically, because I'm updating in Unity 6, say velocity is now outdated and it's obsolete. So I don't know about linear velocity, so I will keep with the velocity, and this will be equal to my velocity. So it's okay if it's obsolete. I don't know about that, but I will check after. So let me just quickly move player, and we want to move the player in the fix update over there. And as you can see here, the velocity will handle the movement of my player will be handled by the velocity. But right now, if I make F over there to looking for all the velocity is not doing anything except here the velocity say of y, it's about the jumping, and on the x is what we are looking for. About the x is equal to get value dot x time speed player, and because it's updating over there, we want to handle the velocity with this callback function over there. So where are they? Over there. So we want to update the get value input over there on the move to be able to update the velocity over there, and because it's calling in the fixed update over there, it will basically move the player on the velocity. And let's go on the onMove function. So here what I want to do, so I will say if callback, so the callback context, so callback context, so where is it? So if the context, so let me just rename this quickly because I like to use callback context instead of context because it's a callback returning the context. So callback context, and I will do the same for the other one because it's not only context here. So if the callback context dot and if the callback context is started, what we want to do, we want to basically say vector2, so vector2 and temp move direction. So we want to create a vector temporary vector2, so temp move direction will be equal to my callback context read value vector2. So basically, this will register what if I pressing on the left, on the right arrow key to be able to check if moving on the left or the right. So this is why we want to put a to do over there, but we'll do it in this video. So we want to need to check if Mario facing left or right, facing left or right. So we need to make basically a function to check this. And also we want to animate our character, so a to do, and we want to animate the character controller. Okay, so after we know that the callback context is started, what we want to do, we want to say get input value, because at the start function we need to check if Mario is going on the left or right. So after it started, so it say we just press the right or left arrow key. What we want to do is get input value will be equal to call context value dot read vector 2D. So we just register our input value to say if going on the left, going on the right, and if so the callback context is performed. So callback context is not started but performed. So as you can see over there, we got different types. So we got the cancel, interaction, perform, phase, but we will say if the user is performs the action, we want to say so previous input value will be equal to get input value, because we already registered the get input value for the next frame. So that's nice. And what we want to make a to-do over there, we need also to handle the animation here. Okay. And next thing we want to do, another if. So we check the start, we check the perform, and if the callback context is cancelled, so it means that the user is maybe stopping the performance. So by pressing the left or right arrow key, we want to handle again. So a to do, we'll make a to do here, and we need to handle the animation of Mario here. And also we want to check, because remember, when Mario is running, we need to handle the slide animation, the slide of Mario when we release the key, when release the key. Okay. So now if we head back to Unity, so let me just quickly head back to Unity and hit play, you will see we'll be able to move Mario left and right. So as you can see, I hold the key like this, like that, and we are able to basically move Mario left and right. And as you can see, if I go on the left, Mario is not facing the good direction, and if I go on the right, he's facing the good direction. But we need to handle the animation. But the animation will be another part of the video, because again, it's a lot to do. So I think I will stop this video over here, because it was a lot to do, and we are able to move Mario left and right. So this is the main purpose of this video. And in the next video, we'll maybe handle the facing direction and also maybe the jump of Mario. Not the animation, but at least the jump. So I hope you enjoyed this video. I hope I make it clear. If you like my content, do not hesitate to subscribe, thumb up. If you have trouble to understand what I make, and if you don't understand how this code works, do not hesitate to comment, and I will be glad to answer your question. But let me just quickly summarize everything up for people who maybe do not understand. So basically here I declare all my variable here. So the sprite, the collider, the rigid body, check if the player is grounded, and we start making like a little piece of code. So with the update function, with the fix update, and as you can see here on the move function, we basically this will handle everything. So this will register if the player is touching the keyboard, so left and right, because remember we were mapping the input action over there. Again, on the move, we've mapping the left and right arrow, and basically when you register it, so the input value is updating. So basically it's updating via the input action map, and because we move the player here in the fix update, so each time you will check it, the fix update will say, okay, the rigid body 2D player velocity will be equal at velocity. But right now the velocity, as you can see, it's only a vector 2 with no value, but the velocity is check here. The velocity is update over there on the x-axis. Oh, and it's updating with the input value. And because it's update on the input value in the update function and after the fix update, via the input value the user is pressing, this is why we are able to move Mario. So I hope it's more clear and more understand. I know it's kind of tricky, but is one way to make this, but trust me, it's a good way to deal with this Mario game. So I hope you enjoy this video, I hope you like it, and I guess I catch you guys next time. Bye bye!